Dr. Schloss has a master's degree in math from Harvard University and a PhD in electrical engineering. And currently, his two granddaughters, Yona and Lena, who are in our lower school. So welcome, Dr. Schloss. And we'll get to hear from him. I am now, thank you to our panelists. Yiladim, let's listen up. I'm going to now hand over the program to Mrs. Segan, who will be your MC.
Our first question is going to be for Dr. Schloss, who's not here, but as it was said, he did record a video. His question is, what is one of your biggest accomplishments from working with the space program?
What is one of your biggest accomplishments for working with the space program?
Knowing that I contributed to the successful landing on the moon and hearing the human voice coming from the moon declaring, "Houston, we have landed."
Thank you very much. We calculate mincha by figuring out when sunset is and having mincha always approximately 10 minutes before sunset. So if you know when sunset is and you come 10 minutes before that, you will be on time for mincha at Green Road Synagogue.
All right, our next question will be for Mrs. Curran. What made you decide to become a science teacher, and why did you decide to become a scientist?
So I became a scientist because I love discovering new things and learning about how the world around me works. And why I became a science teacher was so that I could help other people discover amazing things about why and how the world works.
All right, the next question is for Mrs. Artisman. What is bone density, and what does that mean? What does that have to do with astronauts?
Bone density is the amount of bone minerals per volume of bone tissue. So what that means is the amount of minerals per amount of bone. And the main minerals in bone are calcium, which is about 70%, and magnesium. And what it has to do with astronauts is that when astronauts go into space, they lose bone density, and that's called spaceflight osteopenia.
All right, Mrs. Rudolph, what is Kiddush Levana, and when do we say it? Also, who can say it?
Thank you. Shalom Aleichem, everyone. It's going to be a little bit of a longer answer because there are actually 3 questions instead of 1. The last part of the question first, I think, who can say it? So it's actually a great question, and there are different opinions. It's an obligation, for sure, to say Kiddush Levana. We'll talk about what in a minute. It's Kiddush Levana, but whatever it is, it's an obligation for a man over bar mitzvah. There are different opinions whether women are also obligated. There's a famous opinion that you might hear around that women are not obligated and maybe even shouldn't say it because there are a lot of mitzvahs that not everyone has to do, but they can still choose to do. So with Kiddush Levana, it's a little bit trickier. We'll see that it's basically just a bracha. We want to be very careful about not saying Hashem's name if we don't have to. So there are some different opinions whether Kiddush Levana, if you don't have to say it, whether you should or should not. There are some opinions that say that a woman could choose to say it if she wants, and that's not a problem with saying Hashem's name when you don't have to. Rav Salvation, is a name you might know, actually thinks that women should say it. So there are different opinions and different customs that you'll encounter among women with the Kiddush Levana. So what is this bracha thing? What's Kiddush Levana? We talk about it as a bracha on the moon. Some people actually call it Birkat Levana, right? Like bracha of the moon. Like Cookie Monster says, that you may have heard, it kind of looks like a cookie sometimes, but we're not taking a bite out of it, so it's definitely not that kind of bracha. It's also not a bracha to the moon, and we actually want to be very careful because we know that there have been people throughout history who have worshipped the moon and thought that the moon had power. We want to be very careful to not make it look like that's what we're doing. So some people have a tradition to be very careful not to seem like they're bowing when they say Kiddush Levana, and also saying Aleinu at the end helps with that because we say in Aleinu that Hashem is the only God. So we want to be very clear about that and not seem like we think that the moon is special on its own. So those are things that we're not doing. We're not saying bracha to eat the moon, and we're being very careful to show that we're not saying bracha to the moon. So what we are doing when we say Kiddush Levana, the Gemara says that when we say this bracha about the moon, it's like we're greeting Hashem himself. We're meeting him through his creations. One of the ways that we can appreciate Hashem's power is to admire the incredible things that he created in nature, and especially when we see something that follows a constant pattern and has a rhythm and always does what it's supposed to do, right? Again and again, and it gets bigger and it gets smaller, exactly how it's supposed to do, and that kind of reminds us of the truth and the power of Hashem's role in the world. There's another reason to focus on the moon specifically, because the Jewish people are often compared to the moon. So one way we like the moon is that we reflect light. We're supposed to be an Or Legoyim and show light to the other nations and reflect Hashem's light into the world. There's another way that we have ups and downs in our lives, just like the moon. It gets bigger and it gets smaller. So when we see the moon growing, it reminds us that we can grow too, right? As our nation as a whole, we might have ups and downs as the Jewish people. We also have ups and downs in our personal lives for ourselves. So we say Kiddush Levana specifically during the part of the moon cycle when it's getting bigger. It looks like it's growing, and that reminds us that Hashem can help us grow too, just like He helps the moon grow every time it gets smaller. One more. Oh, yeah. The one question, I told you it was a longer answer because there are 3 questions. Take it around that. So all these answers about the moon and Hashem and how we compare to the moon. So we can only really appreciate those ideas the best when the moon is giving useful light. So we say Kiddush Levana at nighttime, and when it's not too cloudy for the light to shine through. It's best also to say it on a Saturday night, when people are together, often on a Saturday night, coming out of Shabbos. And it's also a time when we're likely to be all dressed up. So big groups and fancy clothing are great for setting the moon to really greet Hashem and with respect and excitement. Another reason that we might want to say Kiddush Levana with people is that there's a tradition to wish each other well after we say it. You go up to 3 people and say Shalom Aleichem, and they respond Aleichem Shalom. So it helps people feel good about each other and it brings us together to face whatever the rest of the month will bring. So that's why I started with Shalom Aleichem, you may have noticed, and with Aleichem Shalom.
Our next question is for Mr. Cooper. How is breathing in space different than breathing on Earth?
Breathing in space is quite different. There's no oxygen, and the air we breathe, we have an atmosphere that holds oxygen in. People need oxygen to live. There's plants on Earth that produce oxygen and get rid of waste and bad stuff like CO2. And none of that stuff is in space, so we need oxygen while we're on the ground and while we're in the air. And as you go higher and higher, there's no oxygen. So to live up in space, you have to have some kind of enclosed unit, or you've seen like the funny spacesuits, and they just give you oxygen. They don't have plants around, but they produce oxygen in other ways.
Okay, our next question is from Mr. Burt. What projects are being worked on at the Cleveland NASA, and what is your job for those projects?
Well, there are over 2,000 researchers and engineers who work at the NASA Center in Cleveland, which is called the NASA Joint Research Center, and they work on many different projects, both related to space and related to airplanes, making airplanes fly faster and quieter and more efficiently. And I'll just mention a few of the larger space-related projects that I've had some involvement with myself. One project that a lot of people work on at NASA then is called Orion, and this is a new spacecraft which is intended to replace the space shuttle that retired about 8 years ago, and also to put astronauts into deep space far away from Earth for the first time since the moon landings of almost 50 years ago. And it's also hoped that about 10 years from now, Orion will be used to help put astronauts back on the moon and eventually to build a permanent moon base where people can live. And there are a lot of different parts of the Orion program that are being worked on at NASA Glenn in Cleveland. And one of them that I've worked on a little is a team developing the controls and guidance systems for Orion, which will be used to help the astronauts steer the spacecraft through space. So another area that a lot of people work on at NASA Glenn is the development and testing of solar electric propulsion systems for spacecraft. So I'll explain what that means. Solar electric propulsion systems use energy from the sun, which is converted to electricity by big sunlight collectors called solar panels, and the electricity is then used to push a spacecraft through space in a more efficient way than rocket engines could do. And the largest facilities in the whole world for testing these solar electric propulsion systems are located at NASA Glenn in Cleveland. And I have worked on a little using big computers to help better understand and improve the results of these tests.
All right, the next question is for Mrs. Rothman. Did Christopher Columbus really discover that the Earth was round, or was it someone else?
Okay. Well, I'm really glad you asked me this question, because this is one of my favorite myths to bust. Because a lot of people probably thought that. Did you guys learn that Christopher Columbus discovered the Earth was round? He didn't. Everybody knew that the Earth was round. The ancient Greeks knew it 2,000 years ago. You can see it with your eyes, right? I bet some of you guys can think of some ways that you can. You see a ship sailing across the horizon. You see the top part of it go down first, and then you see it's, you start to see it going over. And if you look up at the sky from different places, you can see different stars depending on where you are. How else can you see that the Earth is round? There was a man named Eratosthenes a couple thousand years ago who realized that if you stick a stick in the ground in different places, the Earth's shadow is a different length depending on where you are. And he actually used that to figure out how big the Earth was. And he was really, really close to right. So everybody knew the Earth was round a couple thousand years ago. Now some people think that they then forgot it, and that when you get to 1492, Christopher Columbus is the only one who knows it because everybody else has forgotten. That's not true either. Everybody remembered that it was round, and they also remembered how big it was, and they knew that Christopher Columbus was probably wrong about how big it was. He thought it was so small that it would be pretty easy to go the other way and still hit India, and he would have been wrong if there wasn't something in between. So, if you were historians, what you would ask is, how did everybody start thinking that nobody knew the Earth was round if everybody knew that? And that's a really fun question. You can ask me that later, because I don't have time to answer that right now. All right, thank you. All right, Mr. Wolf, when you were in Iceland, what time did Shabbat start and end?
When we were in Iceland, Shabbat started at 8:35 and ended at 10:05.
All right.
I can elaborate more.
Yeah, elaborate a little more.
When we went to Iceland, the first thing we did was ask Rabbi Lau when we should start Shabbos and end Shabbos. And we learned that there's no real good rules of how Shabbos should start and end if the sun doesn't set. So the different opinions are that Shabbos either doesn't start, which nobody really believes in. The other opinions are that Shabbos starts when the sun is the lowest on the horizon. And the other final opinion that most people seem to accept is that Shabbos starts and stops at the same time as the community that you come from. So whatever time it is in Cleveland, that's the time you should start Shabbos and end Shabbos in Iceland. Ultimately, it turned out for us that the city that we were in Iceland had a specific time for starting Shabbos and ending Shabbos, and that's where the 8:35 and 10:05 came from.
Thank you. All right, Rabbi Farkas, has traveling to and from Australia ever impacted your ability to fast and or come in the way of you performing a mitzvah?
Yes. Traveling to Australia from here. Right now in Australia, it is approximately 12:22 a.m. on Wednesday morning. If you were to travel from Cleveland to Australia, you can't, there are no flights that go direct. You'll stop in LA, and then from LA you're going to have a 15-hour flight to Australia. If you leave at night, the sun will never rise the entire flight. It will be dark the entire way through, and you will miss a day. So if you leave on Sunday, you will land on Tuesday. You will not be able to daven Monday's davening. You will not do the Monday Torah reading. If you plan it right, you can miss fast days, skip the days you don't like, and when you come back from Australia to America, that's even more complicated, because if you leave at 3 p.m. on Sunday, what time do you think you're going to land in LA? You're going to land before you left. So it's really, really important to check both the calendar and the Jewish calendar before you fly. Because if you don't, you're going to make the same mistake that I made the first time I traveled back to America, which was fasting twice. Because Asara B'Tevet, the 10th of Tevet, is the longest fast in Australia. It goes till about 8:30 p.m. because it's in the heart of summer, not winter. And so, if you were to get on that airplane at 3:45 p.m., you've got about 4 hours left because the sun's going to set a little bit sooner because you're traveling eastward. So you fast for 4 more hours on the airplane. Finally, the fast is over and you can eat. And guess what happens midway through the flight? You cross the international date line. And it's not Monday, it's Sunday all over again. Now, lucky for me, I called my rabbi and asked him what I should do. And he told me that as long as I was on the airplane, I did not have to fast again because my fast was over. The problem was, as soon as I landed in the United States, I did have to fast again. Now, luckily, the 10th of Tevet is the shortest fast in America. And my flight did leave at 3:45, so it landed at 12:45, which meant there was only about 4.5 hours left of the fast to do, again in America. But it was frustrating that once I landed, I did have to fast a second time.
Mr. Shoaib, how much does space travel cost? Is it cheaper now that we use reusable rockets?
Yes, for sure. So, try an experiment. How many people here have flown on an airplane? Wow. Okay, so a big airplane costs $250 million to build and might have 250 seats. So if we could only use it once, how much would it cost to fly on an airplane? One of the 5th graders. Yeah. Ellie, sir.
Per flight?
Yeah, so if you have 250 million and you have 250 seats. Yeah, $1 million. I bet if we had to pay $1 million every time you flew, maybe fewer of you would actually have flown on an airplane. The reason why it doesn't cost $1 million every time you fly is because we can reuse the airplane. And for a long time, we couldn't reuse rockets. And it's really kind of a new thing that we can reuse more and more of the spacecraft, and that's made it much cheaper.
Great, thank you. All right, the next question is for Schloss, via video again. How do you map out directions for spacecrafts in space?
All right, go.
How do you map out directions for spacecrafts in space?
That's a very interesting question. Because you're out in space, there's no street signs, there's no landmarks. How can you tell where you are? You look around, what do you see? You see the Earth, you see the moon, and you see the stars. That's all you have. So, on the spacecraft, there's a special instrument, and they could measure the direction to a star, and then the direction to a spot on the moon, and measure that angle. And they could measure many angles like that and figure out where they are.
astronauts exercise when they are in space?
So it's important for astronauts to exercise in space to prevent bone density loss. So this relates back to the previous question where we learned that astronauts lose bone density in space. The reason why they lose the bone density is because they're not weight bearing on their bones because there's no gravity. So in order for bones to be able to get new bone cells, you need to have stress on the bones. So the bones, actually astronauts don't lose bone density uniformly throughout their whole body. They mostly lose it in their legs and their spine and their pelvis. So those are the parts that are the most weight bearing. And when new bone tissue forms, there are two types of cells. There are what's called osteoblasts and osteoclasts. Osteoblasts build new cells and osteoclasts take away old cells. And stress on the bones is what triggers the new cells to form. And when there's no stress because there's no gravity, then you lose more cells than you're able to produce. And that's why you lose the bone density. So the exercises that you do would be to put weight and stress on your bones so that you don't lose the bone density. So astronauts in space, I looked up that they have to exercise 2.5 hours per day, 6 days a week. And they're using equipment that puts weight and stress on their bones because they can't do it on their own because there's no gravity. They also, besides just the exercise, they have to also take medication and supplements to help them prevent from losing bone minerals. Just like someone here, if they are an older person, they may start to lose bone density. Actually, what happened was when the astronauts went into space, they used some of that information they learned about bone density to apply here on Earth to the elderly population. And so then they learned that you need to exercise with resistance and you also need to take medication.
Thank you. Rabbi Lau, how do you know when Shabbat is over and it is time for Havdalah? Why do some shuls within the same community give different Shabbat end times?
That's a great question. We know when the time of Shabbat has ended. We say when 3 stars have come out, which really indicates that it's nightfall. What we call in Hebrew, Seder HaKavim. The question is, what size stars? Are we talking about large stars, small stars, and medium stars? Generally, you'll find 3 different opinions. You'll find an opinion that says we can see 3 medium stars, and then you'll make Havdalah or end Shabbat 42 minutes afterwards. That's what you do in Green Road. We're one of the earlier ones. Other opinions say you have to wait for smaller stars, then that would make it 50 minutes. That's if you go to Yom Israel. And then there are those opinions that say you wait as long as 72 minutes. All of them are valid, but they're all different ways of interpreting when we know for sure the stars have come out.
Great. Mrs. Rudolph, can you find a lunar eclipse in the Torah? If so, why does it matter?
So I have not yet found a lunar eclipse in the Torah. Maybe there is. The Gemara does actually talk about eclipses as symbols. So there are 2 kinds of eclipse. So a solar eclipse, the moon blocks the sun's light, so we can't see it. In a lunar eclipse, the Earth gets between the sun and the moon and blocks the sunlight from reaching the moon, so the moon can't reflect the sun's light onto Earth. The Gemara says that each type of eclipse is a siman ra, it's like a bad sign. And the lunar eclipse is considered a bad sign specifically for the Jewish people. So it makes sense that we connect to the moon, right? That we connect the Jewish people to the moon because our calendar follows the moon, and because, like I said before, we're often compared to the moon. The question is, why is an eclipse a bad sign for us? So what does it even mean to say that it's a bad sign? So it probably doesn't mean that the eclipse is going to make bad things happen, because I'll know about astronomy and maybe that eclipses, happen, and that they're just part of the world, they're a regular part of nature, even if they look weird. So they probably didn't mean like, ooh, that's a bad sign, bad things are going to happen. But maybe it's more that the fact that something looks weird might make us sometimes feel like it's a bad sign. It might be something that can make us kind of sit up and pay attention and maybe think about our own behavior and take a chance to make sure that we're doing what we should be doing. Okay, so one reason the lunar eclipse might give us that feeling, that the Gemara kind of suggests, is that unfortunately Jewish people have seen a lot of bad things happen in history. So when something seems off, we kind of pay attention and start thinking about what might happen and how we can stop it from happening. I think there might be also something deeper. One of the ways, as I said before, is that one of the ways we're compared to the moon is that just like the moon reflects the light from the sun and helps that shine on Earth, so we're supposed to reflect Hashem's light in the world so that it shines on Earth. And if the Earth gets between the sun and the moon, then the moon can't do its job. The sun's light doesn't shine. So when that happens, maybe that's a reminder that we should think about whether we're doing our job, right? Are we doing the best that we can to learn Torah and do mitzvahs and show Hashem's light in the world? Or is there something blocking us, like the Earth sometimes blocks the moon? So hopefully we can take the lunar eclipse, and maybe even just the idea of the lunar eclipse, because the actual thing doesn't happen that often, as a reminder to do our best job to show Hashem's light in the world and not let anything block us and get in the way.
Great, thank you. This is Curry. Can you tell us something that you find fascinating about the moon?
Sure. So for me, what I found really cool about the moon, and some of you may have learned about rotation and revolution. You guys learned about that? I think I saw it in your STEM packet. So, yeah, do you want to, anyone want to say what it is? No? Okay. Oh, you do?
Spins on its axis, and also it spins around the sun.
Exactly. So the Earth spins on itself, and it also spins around the sun. So the moon does that too. The moon spins on itself, and also spins around the Earth. Now the really cool thing about the moon is that it spins at the exact same speed that it spins around itself, at the same speed that it spins around this Earth. So we always see the same side of the moon. And my cool question is, what does the other side look like? I think that's really cool. Thank you. Mr. Berg, have you ever communicated with astronauts in space at your job?
Well, the short answer is that no, I've never communicated with astronauts in space. But at the NASA Goddard Research Center where I work, there are a number of experiments that have been managed and developed by people there that have been conducted in space by astronauts on the International Space Station. And once in a while, the astronauts who are working on these experiments in space might need to talk directly with the people at NASA Glenn who are managing the experiments. In addition, when astronauts return from missions to space, they'll often tour all of the NASA centers around the country, including the one in Cleveland. And I've had the opportunity to meet a few of the astronauts during these tours, and I've also been able to meet the director of the NASA Center in Cleveland, who's the former astronaut.
What do astronomers do? They do lots of different things, and they have done lots of different things. They look at the stars and the planets, and they calculate where they are and how they move. They come up with mathematical equations to describe them. They use them to set calendars or figure out when holidays are, or figure out where they are on Earth. They also ask questions about how the universe came to be and how stars live and die. You can sometimes think that what astronomers do with space is what biologists do with people. And how things came to be, but put that out there. Why is it important? I can give you a practical question and less practical answer and the less practical answer. The practical answer is that there's lots of stuff we can do based on astronomical discoveries, like GPSs. Right? If you want to know where you are on Earth, we use astronomical technology. You can think about cameras. The way that they detect light and let you take pictures was developed because of astronomy. You can think about X-rays and security screening. That was also developed as part of astronomical technology. But I think the more interesting answer to that question is that we like to know who we are and what our place in the universe is and where we came from, and astronomy helps us answer those questions. So my favorite astronomer, I have to give you two answers, because they're two people who lived at the same time in the 17th century, Galileo and Kepler. They wrote to each other, they were friends, and they had lots of debates about space. They were also two of the first people who argued that the sun is at the center of the solar system and not the Earth. And they had debates about how you know that. Galileo said, I know how you can prove that the Earth moves. It's the tides. The Earth moves and it slashes around and the water moves back and forth. And Kepler said, no, I think it's because the moon is pulling on the oceans. And Galileo said, that's crazy. Yep. Anybody? Call it out. Who was right? Kepler was right? It was gravity, but they didn't know that then. And the reason I like Kepler a little bit, I'll just tell you this really quickly, is because they also had a debate about how much they should share what they knew. Kepler decided that it was important that everybody know what he found out so that science could move forward. So he told everybody every discovery he made. And Galileo kind of liked to keep things to himself because he wanted to be the first to discover things. So when he made discoveries, he would sometimes send them to Kepler a code, and he would say, I discovered something. Here's a code for what I discovered. And Kepler would try to figure it out, and he would say, I can't solve it, tell me what it is. And sometimes Galileo wouldn't tell him for a few years, it really frustrated him. But they were fun pair of friends. Okay, thank you. All right, Mr. Shoad. Mizrachi Lunar Lander is a privately funded enterprise, but is considered a national project. Can you please explain how that works?
Sure. So it used to be that all the other projects to the moon were really driven by the government, but this is kind of a special one because it's mostly driven by tzedakah. So the Israeli government has given some money, but it's people who gave on their own tzedakah to make it happen. But even though that's the case, it's still really a project of the Jewish people. There's, Israeli universities are very involved. There are 200 volunteers, and you guys probably learned that 250,000 Israeli school children help contribute to the time capsule that's going up. And so it's really a project of all the Jewish people.
Mr. Cooper, it is silent in space, so when an astronaut is out in space, can they hear their own heartbeat?
That's an interesting question. First of all, you can't hear anything in space, and the reason is there's really no molecules, and sound travels across molecules. It makes molecules vibrate. So there's no sound, you can't produce sound, but if you could hear in space, if you could hear your own heartbeat, the only way you could hear is because you have these intricate different devices in your ear that actually pick up conduction, sort of vibrations in your body. But nobody really knows if you can hear in space or not, because when people are out in space, they have spacesuits on and other things. So we really don't know, but the thought is that you would hear sort of movements in your body, but otherwise, no, you could not hear your heartbeat.
Great, thank you. Rabbi Fuchs, what were the challenges you faced being a rabbi in the Southern Hemisphere compared to being a rabbi in the Northern Hemisphere?
I don't know that there's so much challenges, there are more differences. For example, what is the earliest anyone in this room has ever started a Seder? Has anyone ever started a Seder before 8 p.m.? Has anyone ever finished a Seder before 11 p.m.? So this year in Cleveland, the earliest I believe that you can start your Seder, according to my Zmani math, is 8:54 p.m. Which means if you rush really quickly through Magid and you don't have a lot of food to eat and you're a fast matzah eater, maybe if you're lucky you'll finish by midnight, if you're lucky. In Sydney this year, the Seder can begin at 5:58 p.m. It was amazing. Another challenge, Tisha B'Av, longest fast of the year? I don't think so. It's over by 5:30. How awesome is that? But Asar B'Teva, as I mentioned before, not so much. It ended at 8:30. Hanukkah, it's our winter holiday, right? Well, no, in Australia, it's a summer holiday. So here we can light Hanukkah candles 5 p.m. Everyone's waiting for the father or mother to get home from work so we can all light before we eat dinner. In Australia, you cannot light Hanukkah candles till about 8:30 at night. When we first moved there, my daughters, Miriam and Shira, were 4 and 2, which meant they had to go to bed before Hanukkah candle lighting. So normally you're supposed to keep your windows open, your curtains open, let everyone see the mitzvah, Pirsumei Misa, advertise the world, we're celebrating Hanukkah. We closed our curtains so our kids could light the Hanukkah candles because it was too early to light Hanukkah candles. We didn't want anyone to see that we were doing the wrong thing, but we wanted them to be able to light before they went to sleep. So that was a bit of a challenge. Pesach is called Chag HaAviv, the spring holiday. Well, not in the southern hemisphere, it's the fall holiday. I had a farmer in my congregation, and I asked him if he could try to grow an etrog. It's the right climate in Australia. They said the problem is the seasons are backwards. The etrog will be ready Pesach time. It will not be ready in time for Sukkot. So I wouldn't say that there's so much difficulties or even challenges. There are just differences and interesting aspects of being in a different part of the world.
Great, thank you. And this will be our final question. It is, again, the via video question for Schloss. Why does it take less gas to come back from the moon than to go to the moon?
Why does it take less gas to come back from the moon than to go to the moon?
That's a very interesting question. So, when you're leaving the Earth is very big. Here's the Earth, and the moon is maybe this big. So, the Earth is, you want to go to the moon, but the Earth is pulling you. So think of a bowl, and the Earth is in the center, and the moon is up here. So you're going uphill. You're fighting the gravity to go there. So you need a lot of gas. And then when you're coming back, you're sort of coasting towards the Earth. And the same thing applies if you're going to Mars. I worked 54 years ago. 1964, several of us got a contract at North American Aviation, was the prime contractor on Apollo, to do a study of a manned Mars flyby mission. And so when you leave the Earth and go into space, the big force is the sun. So you can think of the sun at the bottom of the bowl, and if you're going to Mars, you're going uphill. And you have to have a lot of gas to do that in time. So on a manned Mars flyby mission that we planned at that time, it would take 9 months to get up to Mars and only 3 months to come back. But when you came back, the sun is pulling you so much, you come roaring back to Earth, and unlike the Apollo mission, where you have a corridor that you have to get into to land properly on the Earth that's maybe hundreds of miles of width. When you're coming back from Mars, you have to hit a corridor that's only 10 miles wide. Otherwise, you'll skip out into space, or if you go below, you'll crash on the Earth.
Again, I just want to take a quick thank you to our parent panel for taking the time in the morning to answer our questions and enrich our STEAM learning. So thank you very much. All right, at this time, we would like the parent panel just to stay seated for 1 more minute. Students, you're going to be dismissed. If you have a parent that is up here on the stage, we ask that you stay back in your seats for just a minute to get a few pictures. Everyone else, you're going to get dismissed by class. All right? So you start with first grade.